Greetings, math fans. All right, this is day one of chapter one of calculus. All right, this is calculus A, and actually, this first chapter is a lot of review in here. A couple of new things, but this definitely the first day is really a lot of review of 328. All right, so we're going to kind of go through this quickly. This is actually some algebra from Algebra 1, but just to kind of review a couple basic concepts and that we definitely need to use when we start getting into calculus. All right, we're going to use our graphing calculator today too, so you might want to have that handy. All right, so let's start out here. And this is chapter 1, day 1. And I'm going to put on here, this is just a total review. Okay, you guys really should know this, but that's okay. We'll just go over it. All right. So first thing, slope. M. M stands for montaña, which is French or Spanish, I believe, for slope or mountain, right? That's how they get it. Okay. So anyway, slope is y2 minus y1 over x2 minus x1. All right, and of course, the way you remember this is the good old yax. Okay, this is actually where the yax came into being. Okay, with slope. All right. Couple other things here too. Equations of a vertical line. Okay. Remember that's x equals 105. Okay, that's a vertical line. Okay. And then of course a horizontal line is y equals 105. Okay, and again, I know it's a goofy thing, but I always remember that. You have a y, and I can write a y like this, and if you flip a y or rotate a y 180 degrees, you get h for horizontal. Okay, that's why y is a horizontal line. All right, and if I said it was passing through, 2, 5. If I asked you for a vertical line, you would say x equals 2. If I asked you for a horizontal line, you would say y is equal to 5. Okay, pretty straightforward. All right, we so 3 forms you can put these equations in. Okay, the nice thing about the AP exam is they don't really care what form you put it in. Okay, so you want to put it in the one that's easiest. All right, so the first one we're going to talk about is general. You don't need to be absolute here, okay, but it's general as in it's very generic, and general or linear. Okay, and that is sometimes we call this standard form. And that is going to be ax plus by equals c. Okay. Now, a, b, and c are integers. Make sure you know that. And a is always positive. Okay. And then we have our slope-intercept form. And that's just y equals mx plus b. We already talked about slope is m and b is your y-intercept. All right, and then the last one, which actually is really handy, is called the point slope form. Okay, and that's going to be y minus y1 equals m times x minus x1. All right, so let's do an example here. Given 2 points, find the equation in all 3 forms. Okay, so you get 6, 2 and 2, 4. All right, you want to start with the easiest one first, math fans. All right. So what we're going to do is you don't want to start out with standard form. That's actually the last one you're going to deal with, okay? What you want to do is you want to start out with point slope form first. So that was the easiest. Okay? Because really you just need our slope. So m is equal to 4 minus 2. Again, make sure you do y over x. 2 minus 6, which gives you 2 over negative 4, which is negative 1/2. Okay, and then it doesn't matter which point you use, so obviously there's two answers. So if I do y, let's just do the let's do the first one here. Y minus 2 equals negative 1/2 times x minus 6, or y minus 4 equals negative 1/2 times x minus 2. Okay, either one of those is acceptable. Okay, that's the first one. That's A, and then B is going to be in slope-intercept. Okay, and that's easy. That's just distributing this, and it doesn't matter which one you do. So we'll do the bottom one here. So it's y minus 4 equals negative 1/2 x plus 1, and then add 4 to both sides. So y equals negative 1/2 x plus 5. Okay, that's slope-intercept form. And then standard form is basically you want to get that to be a positive value and for that x, but we need to move it over, right? First thing you want to do is you want to get rid of the fractions. So I'm just going to multiply this whole thing by 2. That gives me 2y equals negative x plus 5, and then add x to both sides, and I get x. Make sure you put your x first. X plus 2y equals 5. Or equals, this should be a 10 here. Sorry, math fans. Okay, so that's 10. Okay, and that's your standard form. X plus 2y equals 10. Pretty mellow. Pretty mellow. All right. All right, let's talk about parallel and perpendicular lines. What other word can we use instead of perpendicular? Orthogonal. That's from last couple chapters ago, right? Okay, so let's talk about slope. When we did vectors, we kind of talked about this already. But parallel means same slope, and perpendicular, remember, it's opposite and reciprocal slope. And what I mean by that is if you have a slope of 5, opposite reciprocal, it means you change the sign and you flip the fraction. That's all it is. So it's m is equal, it's negative, and it's 5 over 1, so it's 1/5. So it's negative 1/5. All right. So here's an example. Find an equation perpendicular and parallel to 2x plus 3y equals 82. Brutal! 82? Gah! Alright, and passes through negative 6, 4. Okay, and I want in slope-intercept form. Alright, well, you got to think about it. First of all, math fans, what do I need out of this equation? Really, the only thing I need is a slope. So I'm going to solve for y. So I get 3y equals negative 2x plus 82. And again, that 82, I don't really care about it because it's just a y-intercept. So y equals negative 2/3 x plus blah. Okay, I don't really care what it is. But it is 82 over 3. Okay, and so I'm going to pull out my slope. My slope is negative 2/3. And now it's kind of nice. Let's kind of work our way over here. If I want to do parallel first, those are two parallel lines. We have a point, so let's put it in point slope form first. It makes sense to do point slope form. So it's going to be y minus 4 equals negative 2/3 times x plus 6. So y minus 4 equals negative 2/3 x minus 4. And add 4 to both sides, y equals negative 2/3 x. Okay, that's a parallel line. Perpendicular, okay, it just means I'm going to take that slope, I'm going to flip it over and change the sign. So my new slope is positive 3/2, and do the same thing. So it's y minus 4 equals 3/2 times x plus 6. Pretty easy. y minus 4 equals, 3 halves x plus 9. Add 4 to both sides, y equals 3 halves x plus 13. And there we go. Okay, that's pretty mellow. Okay, let's try another problem here. For what values, I'll put that S in parentheses, what values of k are these equations parallel? Okay, so we're going to have 2x plus 5y equals 10, and 3x minus ky equals 6. Well, really what we need here, again, when you see the word parallel and perpendicular, you're probably dealing with slope, so we really need to solve for y and put it in slope-intercept form. All right, so solve for y, and I'm going to get y equals negative 2/5 x plus 2, and the other one I get y equals 3 over k x minus 6 over k. Okay, so really the only thing I'm concerned about right here is just the slopes. Okay, and I'm just set them equal to each other because they're parallel. So negative 2/5 equals 3 over k. Cross multiply, you get negative 2k equals 15, so k is equal to negative 15 halves. Okay, what about, let's just do the same problem here, but let's just say perpendicular. Well, the only thing that's going to change here is you have your one slope is, instead of being negative 2/5, our slope is positive 5 halves. Okay, so we're just going to say 3 over k, instead of being equal to negative 2/5, you're going to be equal to the opposite, reciprocal. So 3 over k is equal to 5 over 2. So 5k equals 6. K equals 6/5. Okay, not too bad. All right, so let's talk about something, composite functions. Okay, I don't know if you guys remember that. Composite functions, like you do f of g of x and g of f of x, but a composite function is basically outputs are used as inputs to another function. Okay, outputs are used as inputs to another function. So let's just, quick example here. F of x equals 2x plus 3, and g of x is equal to x minus 7. Okay, so if I want to do f of g of x, basically what I'm doing is I'm substituting g of x into f of x. So literally, g of x being x minus 7, that's going into that x right there. So that's going to equal 2, and what 2x? Well, what's x? X is what I'm plugging in. That's the g of x. That's my input, and that's minus x minus 7 plus 3. So it's 2x minus 14 plus 3. So that's going to equal 2x minus 11. Okay. Okay? Pretty easy. Okay, and here let's try a couple other ones here. How about g of f of x? Well, that's just taking, again, you're taking that f of x and you're plugging in where you see an x there. So instead of x minus 7, I'm going to take x is going to be replaced with 2x plus 3. That's x, and then minus 7. Okay, and that gives you 2x minus 4. Okay, here's another one here. F of x. Well, that's just taking wherever I see an x, I'm going to put a 2x plus 3 in there. So it's 2 and 2x plus 3 plus 3. Okay, that gives you 4x plus 6 plus 3, or 4x plus 9. Okay, and remember, just other notation. Okay, so f of g of x. Remember, you can always still write it as f. That's the other notation. It looks like fog. You guys probably remember that from Algebra 2. The fog. And then, of course, g of f of x is Goff. Okay? Pretty straightforward. So if I said f of g of 2x. So it's really saying f of g of 2x. So what I can do is I'm going to put 2x into where g of x is. So it's really f of, and then g of 2x is, you stick a 2x where you have x plus 7, so you have 2x minus 7. Right? Because that's what g of x is, again, your x minus 7, so I'm putting a 2x in there. And then I take that and I put it into 2x plus 3. So it's really 2 times 2x minus 7 plus 3, or 4x minus 14 plus 3, or 4x minus 11. Okay? So that's just kind of some basic things with composite functions. All right, let's talk about even and odd functions. Okay, a function is even if f of negative x equals f of x. Okay, so basically what you're doing is you're plugging in a positive and a negative value. So you plug in a positive and negative value, and then they must equal. Okay, so you plug in a positive. So really good thing to do is you plug in a negative one and a positive one. We're going to do a couple examples here, but you plug in a 1 and a negative 1. If the answers are the same, it's an even function. It's really easy. Okay, odd. Basically, if f of negative x equals negative f of x. Okay, so this one you plug in a positive and negative value, and the output has opposite signs. Same value, but opposite signs. Okay? So what this one is, you plug in a 1 and a negative 1, and the answer comes out to be a positive value of something and then a negative value of something. And so they have opposite signs. That means it's going to be an odd function. All right? Pretty reasonable. Okay, so let's do an example here. Y equals x squared plus 5. So I'm going to plug in plus or minus 1. Okay, well, if I do 1, I get y equals 1 squared is 1 plus 5 is 6. And I put a negative in there. Negative 1. So negative 1 squared is also 1 plus 5 is 6. Okay. Even function. Well, that's pretty easy. Okay, let's do next example here. y equals x cubed plus 5x. Okay, so again, I'm going to plug in plus or minus 1. So, I'm going to put a positive 1 here first. And I get 1 plus 5 equals 6. Okay? Put a negative 1 in there. Negative 1 cubed is negative 1. Minus 5 equals negative 6. Hey, opposite signs. Odd. Okay? Yeah, one more example here. How about y equals 2x cubed plus x squared? So again, I can do 1 and negative 1, so I'll plug in positive 1 first. And I get 1 cubed is 1 times 2 is 2 plus 1 equals 3. Put a negative 1 in there. Negative 1 cubed is negative 1 times 2 is negative 2. Negative 1 squared is 1. Oh, look at that, man. Okay, so I get 3 and negative 1. So this is neither. Now, if you notice, let's look at these 3 problems here, math fans. You notice for the first example, those are even exponents. And you're like, well, wait a second, Mr. Curvis, that 5 doesn't have an exponent. Well, it kind of does, right? Here, right? 0. It's actually x to the 0, right? That's what I'm looking for, x to the 0. So yeah, it kind of does have a 0 exponent. So if it's even, all the terms have to have even exponents, which includes constants, because you get x to the 0, which is 1. Okay, and then if it's an odd function, they all have odd exponents. Okay, and then you can see the third example is neither, because you have an even and an odd exponent. And it kind of makes sense. If you have an even exponent, when you square something or raise something to the 4th power or to the 0 power, it becomes a positive value, right? All the time. So it doesn't matter if you put a negative value or positive value, it becomes the same value, and that's why it's an even function. As opposed to an odd function, it's when you put in a positive value, you get a positive value. When you put a negative value, you get a negative value, no matter what you plug in. And when you have a mixture of it, you can't have that, right? It's not neither an even nor an odd function. All right. So what about a couple of them here? What about y equals x to the 105 minus 2x to the 11th? Well, of course, it's an odd function. Okay. What about y equals x to the 20th minus 3x squared plus 105? Ooh, very scary. Okay, remember, that is like saying 105x to the 0. So that's an even function. Okay, and, even like graphically, an even function is going to look like, let's say we have y equals x squared, which is an even function. Right? It kind of looks like this. And what this is, just to kind of give you a little information here, an even function is symmetric about the y-axis. Okay, and an odd function, so this is, it says this is y equals x squared. So if I said y equals x cubed, it looks kind of like this. Okay, and this is actually symmetric about the origin. Okay, symmetric about the origin. And just like you can kind of compare the two. If you put in a positive value or a negative value, you still get a positive value. You get the same value. As opposed to if I'm over here, right, this is like negative 1, or positive 1, this is going to be negative 1. Okay, one's positive, one's negative of the same value. Okay, and that's, of course, the x values, right? You get the opposite values for y. Okay, so how about this one? This is a really good question. I'm going to write good question. Y equals the square root of x squared minus 4. This is even or odd. Okay. Well, it's a little tricky, isn't it? Because you kind of look at it and it's like, well, am I taking the square root of that number? Or, so am I looking at the x squared, or am I looking at the square root after you take the square root becomes just x? So it's a little tricky. So again, if you're not sure, plug in a value. Okay? So plug in plus and minus of some value. Now obviously it's got to make sense. It's got to be a value that's in the domain, and you can't just plug in a 1 because you get 1 squared minus 4, you get a negative value. You can't take the square root of a negative number. So I'm going to choose, just for the heck of it, plus and minus 3. So if I do 3, positive 3, I get 9 minus 4, which is square root of 5. If I do negative 3, I get negative 3 squared is 9. 9 minus 4 is 5. Ah, same value. It's an even function. Okay? That's not too bad. All right. This next part, math fans, is a handout that you guys are going to get in class. I worked very hard on this handout. It's the lines of regression on the TI-84. Okay? And so it's this handout here. Again, have this in front of you. I'll just kind of, scroll through it here real quickly. But I'm not going to have this on the screen. You just need to have this in your hand. But basically what it does is it kind of shows you a little bit about regression. Regression is really predicting. Okay, in other words, you're going to be given a bunch of data points, and first of all, does it look like the graph is linear if you plot those points? Is it quadratic? Is it cubic? Is it quartic? Whatever. But you are going to kind of make an estimate of what it is, and really I'm going to tell you whether it's one or the other, cubic, quartic, whatever. This is just a really good handout to help you understand how to kind of type things in your calculator. All right, so bring up the virtual TI. Okay, it's kind of nice. I kind of shrunk it here a little bit so you can kind of see everything. And let's just kind of go through the keystrokes. Again, you got to have this line regression handout in front of you. It's just going to make it a lot easier to know how to do this. But you have to know how to do it. Practice it on some problems, whatever. But on a quiz and test, you're going to be given a graphing calculator, and you're going to have to know how to come up with an equation. All right, so make sure you know the keystrokes here. All right, the first thing I want to do is I want to reset the list. Okay, and to reset the list, because you notice on your handout it says L1, L2, L3. Sometimes what happens is you don't see an L1, you just have an L2 because you can delete it. All right, and real quickly here, here's L1, L2, L3, and let's just say if you did delete it, and you see how, look at, I'm on L3, I got rid of L2 and L1, like, oh man, how do I get that back? Well, this is that first step. So you actually, let's kind of quit out of here now, and I'm going to go to Stat and hit 5 and hit Enter. And if you hit Stat, edit again, L1, L2, 3, everything's back to normal again. Okay, so it brings back all your columns. Okay, so second mode, which is it quits out of there, right? All right, so what I'm going to do is now I'm going to go to y equals and make sure everything is cleared out of here. So if you had 9x whatever inside here, just make sure you hit clear. Go up to whatever you have. Just get a cursor to the different ones here, and we have nothing in here now, which is good. Okay, now I need to turn on our scatter plot. Our scatter plot actually is the thing that's going to graph our points that we're going to give it, our data points. So I'm going to hit second y equals, hit enter because we're on plot 1, and I'm going to cursor, actually it's on there already, hit enter, and turn it on. Okay, and then see this x list is L1 and y list is L2. That's what we want, because we want the L1 to be our x value and L2 to be our y value. All right, so again, second quit to get out of there. And so we go to Stat, and we go to Edit, And if there were values here, let's say 9 and 3 and 6, let's say there were some values in there, what you want to do is go to the top of the list. It says go to the header of the list. Don't hit delete, because if you delete, you're going to actually get rid of that column. You hit clear and enter. And it clears everything out. But it doesn't get rid of the column. Very important. Don't hit delete. Okay? And then in order to add data into the list, you're going to just type the values in. L1 is your X values, L2 is your Y values. Okay, and I even have it on here. Make sure that they're the same number of values, otherwise it's going to give you an error. All right, and so let's actually, I know I'm kind of skipping ahead here, but let's type in the data just to kind of help us out here to see what we're going to have. So we got sample data. I have 5 different cars, and their cost and the top speed. So the cost is going to be our X value, and the top speed is our Y value. So let's kind of put things in here. A Honda Civic is $18,000. I had a Civic at one time. It's a great car, totally bulletproof. Not literally bulletproof, but an awesome mileage too. Okay, a Camry is $22,000. Very reliable vehicle. An Impala, which is a very popular General Motors car, $25,000. A Mustang, my brother had, or he still has a Mustang. It's a very nice car. Okay, they've done a lot to the Mustang. And then a Corvette. That was always my dream car, but I don't think I'll own a Corvette anymore. It's kind of small and not too practical. Okay, so I got all that in there, and a little history of my life now too. And then I just hit the right arrow, and it brings you to the top of L2. So the top speed of a Civic is 120 miles an hour. Not bad. Camry is a little faster, 135 miles an hour. Impala. I think that might be the Impala SS, but it's okay. 145 miles an hour. The Mustang goes a little bit faster. Oops. I want 155. Okay. And Corvette, 185 miles an hour. That's fast. Don't speed, guys. If you go that fast, they don't give you a ticket. They send you to jail. Okay, so we've got our data points in there now. Let's go back to on top here now. It says, so we entered all our data in there, right? L1, L2. Now we're going to hit zoom, so we can quit out of here. It's just kind of good. We can hit zoom, because you don't want to just graph it right away. And if you look, our different ones, we can just hit directly. Zoom, stat, and stat is the different stats that we just put in. So zoom 9, just hit a 9 also, or you can just cursor down. And there are points. Okay? If you don't see points there, that means your stat plot is turned off. All right? And now we're going to do, it's this next step, getting the regression equation. A regression equation, again, is going to be an equation that we can use to predict values. Okay? So in other words, how much does something cost, and then what is our top speed? That's what we're predicting, the top speed. So remember, do not hit enter. That's what it says on there. Do not hit enter until the entire step is complete. So we're going to hit stat, and we're going to cursor over to calculate, and then we're going to choose 4, linear regression. Notice it's got linear regression, quadratic regression, cubic regression, quartic regression. Okay, notice that because you're going to use that at different times. I might tell you this is a quadratic, or this is a cubic, or this is a quartic. So watch what I'm asking for. Okay, don't just automatically go, oh, just go linear regression. All right, so this is what I told you. This is linear regression. Don't hit enter. Okay, and now we're going to hit the vars key, which is right over here. So vars, cursor over to y vars, function, hit enter, and y1. So now we have, this is what we have on the screen, linear regression, parentheses ax plus b, close parentheses y1. Now you hit enter. And math fans, what this did is, first of all, it not only calculated our equation, okay, so it's y equals ax plus b, so it's y equals 0.0023 blah blah blah, x plus 83.4337 blah blah blah. So it came up with our equation. But the reason we put that y1 in there is, watch, if I actually hit the y1 button, it put it in there for me. Okay, if I didn't hit y1, that vars y1, I would actually have to type it in manually, and especially when you get all these nasty decimals, it's kind of hard. But it puts it in there for you. That's pretty sweet. And so let's we don't have to zoom now. We should just hit graph, and oh, look at that. There's our line. This is called the line. This is a regression line. It's called line of best fit. Okay, it's fitting that line to the data points as best it can, and then it's linear. Okay. Now what we're going to do is we're going to predict. We came up with an equation, so now we're going to predict. Well, the first thing we want to do, again, it says predicting based on your regression equation. Press the window key. Because see that X min and X max? When I predict, I have to have that window, or the value I'm predicting, that has to be between the X min and the X max. Otherwise, it's going to give you an error. And let me just show you really quickly if I don't correct it. Okay, let's quit. And I'm going to do second calculate value. Just want to show you what happens if you. So if I type in the first one is $180,000 Ferrari California, which is a totally sweet car, and I hit enter. Look at that. Okay, error invalid. So that's the deal. Is my window was not correct. So let's quit and let's go to window. So what I'm going to do is notice I've got two things here. I've got to go up to $180,000 Ferrari California and down to my bike. So I'm going to make my minimum. It doesn't matter. I can make it 400. That's cool. And I can make my maximum 180,000. Okay, that's all I have to do. That's my X min and X max. Okay, notice it kind of changed the graph. See this little icon, this little thing down here? It kind of shows you about graphing and everything, or what the graph looks like. In fact, even if I did the graph, it changes it, but it's still got the same equation. Okay, it just changed the scale. All right, now second calculate, and let's put 180,000. Oops. Let's do that. Second calculate value. 180,000. Okay, so the top speed, there it is, 498.5 miles an hour. Well, that's not very realistic. And just because you typed in a whole bunch of data doesn't necessarily mean it's going to work out. In fact, it could be a quadratic regression line. Okay, you don't know. So sometimes you're just trying different regression lines out. But a Ferrari California cannot go 498 miles an hour. That's about what a jet airplane does in the air, maybe a little bit slower. Okay, but anyway, but that's what that prediction is. 400, almost 500 miles an hour. Okay, and now let's do second calculate. Let's predict another value of me on my $400 bike. Let's see how fast my $400 bike can go based on this regression. Ah, look at that, sweet! It says I can go approximately 84 miles an hour. Okay, probably not. I don't think you want to go that fast on a bike because if you fall, you will die, and that's not a good thing. All right, but anyway, that just kind of gives you a prediction, and probably something more realistic. You know, if I had, I don't know, a $35,000 car. So we can just put this in here. Second calculate $35,000 car. Put that in there. 35. How fast is that going to go? 164 miles an hour. That might be kind of realistic. A little more souped up Mustang, or maybe a Porsche Boxster or something like that. That's more realistic. Anyway, that's it, math fans. That's line of regression. There's a lot of review here. Hopefully you learned something in this lesson. And for tomorrow, we're going to do a lot more with graphs. Okay? That's it, math fans. Have an awesome day. Adios. Goodbye.